All right, we have the Math 1111 Zoom meeting. Thursday, November 12th, 9 p.m. Got a participant tonight. Can you hear me?
Yep.
Okay, did you have any questions tonight?
None. Think of.
Well, Monday noon, I gave a pretty good description or introduction to everything, worked a lot of problems. And then Monday night I canceled. But this noon I worked, again, examples of everything. Is there, I don't know if you want me to keep doing that. I can go through each section, work examples. Or was there anything in particular you might be having trouble with or wanted to see? Oh, we have another participant, Mr. Clark. Appreciate you coming out tonight. Can you hear me, Mr. Clark?
Yeah, totally.
Okay, did you have any questions tonight?
Oh, no, I understood this week's stuff pretty well.
Okay. Well, Mr. Paul doesn't seem to have any questions, so all I know to do is just, again, walk through the sections and work examples. I don't know, it might be, if you understand
Awesome,
everything.
sounds good.
It does, okay. So you understand how to, try not to repeat the problems I've already worked. It's hard to remember which ones I've worked and which ones I haven't, but this is the very beginnings of 4.3. I don't think I've worked anything from the B column. I can try 11. Let's see, further up. Things will 11b there, log base 10.01 equals -2. It's off page 387, 11 part B. Log base 10 equals -2, and they want exponential form. Don't seem like we're working like a well-oiled machine tonight. It was working pretty good through 12 today. Well, basically in exponential form, you use base 10. You usually write the 10. When you see the word log, they mean base 10. You base 10 and you'd raise it to the -2 power. It'll catch up. And it's equal to 0.01. That's what they mean by exponential form. Can y'all do that quick, or do we need more steps for explanation?
I can do that pretty fast.
Okay. So in the next section, 17 on, they do the reverse. They give you an exponential form and want log. So maybe we can try 23A and B. So it's off page 388. 23A is e to the x equals 2. They want a log form. We'd use ln because it's base e, in which case we'd have log e to the x equals ln of 2. I'm writing out more steps on this one. Got the cord coming right across me. There we go. Yeah, not a well-oiled machine tonight. I don't know. No one else is on at my house. Sometimes it's because my, see, I've moved the cord, but it's still showing on the screen. Well, I'm really frozen here. I don't know if I should. Okay, it's show the cord being moved. In any case, these undo and you have x equals ln of 2, or in effect, ln of 2 equals x. ln of the 2 equals the x. There we are. Okay. Anybody have any questions or anything off the web assign? Hate to show you stuff you already know, but don't really have much choice. Want to see something from the next section? That would be about evaluating logarithm. Sure, okay. So some of these, like 32 is pretty simple. Some of these, they've really lined up the e and the ln, and so that answer is just root 3. This answer is 1 over pi. This answer is 13. They've really lined them up. But some like 33a, they haven't. There's a lot more work in something like 33a. There isn't in B. B is 4, and C is be e to the -1, be a -1. But 33a is a real project. Do you want to see something like that?
Sure.
Okay. Because you can see that it's not really obvious how to write 0.25 with a base 8. This is still off page 388. Yeah. I want you to evaluate log base 8 of a 0.25. So you've got to write with a base 8. Not exactly obvious how to do that right off the bat. So you basically just sub in stuff you already know, and hopefully you can get there, meaning that would be a log base 8 of 1/4. 0.25 is 1/4. Okay. We can try going back to a 2, log base 8 then of 1 over 2 squared. I'm just subbing in stuff that I know is equal. So 2 squared is 4. So it'd be 1 over 4 is 1 over 2 squared. Well, then I can move that up, and that's a log base 8 of a 2 to a -2. See, this is still not -2. These do not match. So I can, I do know to the relation between 8 and 2, I do know that a 3rd root of 8 is equal to 2. So I can go a log base 8, 1, or well, it's a 3rd root of 8 raised to a -2. Are we losing anybody? Should we pause for station identification? That's maybe I should make it more obvious. That's a 3rd.
I'm good.
Okay. Well, a 3rd root of 8 is a 1/3 power raised to a -2. And when you raise to powers, they multiply. Log base, that's a log base 8, lost the base. Log base 8 of 8 to a -2/3 power. And now I have what I want. My log base 8 cancels the base 8. My answer is -2/3. So a lot more steps on that one. Should we put a whole bunch of those on the test?
Probably not.
Yeah, I always miss the mood. Should we keep going through the sections or?
Sure.
All right. So the next section has some beginning equation solving. Maybe there's an X and they want you to find it. That's from 35 down to 44. Let's see, why don't we try something like 43B? Page 388, part B of 8 is equal to 3/2. Solve for X. All right, so all you can do is go X to a log base X of 8 is equal to X to a 3/2. These will undo each other, leaving 8. 3/2. Well, that's hard to figure exactly what the 8, you can sit, you might be able to sit here and think of it, but basically then you want to raise to a 2/3 power. So 8 raised to a 2/3 is equal to X to the 3/2 raised to the 2/3. It'll catch up. Yeah, and then see, these will undo each other given X. And so I've got to figure out what 8 raised to a 2/3 power is. I don't know if you've lost my voice. My internet, it says my internet connection's unstable. Am I back? Can you hear me now?
Yeah.
Okay, if it'll unfreeze. There we are. Well, you can, if you want to simplify this, you can, 8 is a 2 to a 3rd power is equal to 8. You can see that over there on the edge. So 2 to a 3rd power, put that in for 8, raised to a 2/3. When you multiply these, 3's cancel, you're left with 2 squared equals X, or 4 equals X. So the X works out 4. So a few more steps in that one. But the really simple ones you should beg me to put on the test are 45 and 47. Do I even need to do any? They want you
Down
to
to see 47.
you want to see 47?
Yeah, sure.
Okay. Well, they're telling you LOG means the LOG key on the calculator, which is base 10. And LN means the LN key. So both of these keys are directly right on the calculator. So when I go 388, 47 part A, LN of 5, they literally want me to punch LN of 5, natural log of 5. Natural, you punch it just like it's written, natural log of 5. 1.0694. Sometimes they give you the number of places. It says 4 places. I'm not a stickler. 4 places would be 1.6094. You know, the key is if it says LN, punch LN. If it says LOG, punch LOG. I have met people who punch LN no matter what it says. Everything's an LN to them, even if it says LOG. Needless to say, these people do not get good grades. Do we need to see any more of those?
No, I think I'm good.
Okay. Let's see. The very last section was they give you a formula, a log kind of formula, and they want graph, domain, range, and asymptote. Do you need an example of one of those?
Yeah, with that one, I might need an example.
You want to pick one out?
Um, 68 maybe?
All right, an even one. So 1 minus log base 10 of x. One minus log, they wrote a 10 of x. Want a graph? Domain, range, asymptote. Of 1 minus log of x. The graph, and it would appear that we are, it's hard to draw these things clearly what's going on. Let's see. I don't know if I can show it any clearer if we take out more x max and more y max. Shorten up. Let's go 0 out to 20 and 0 up to 20 and see if it shows any clearer. Okay. Yeah, what's going on? It's approaching the y-axis as an asymptote, but you can see it's actually crossing the x-axis. It's not really showing anything below the x-axis, but it is crossing and kind of going off. So your vertical asymptote is going to be x equals 0. Can you tell your range negative infinity to infinity? Your domain is going to start at 0 and go off to infinity. And then you have your graph there. Questions about that?
None here.
Okay. Well, that pretty much is an example of everything in 4.3. If we go to 4.4, basically 3 laws of logarithms. Do we need an example of those?
Sure.
You know what they are? You use ln. If you multiply 2 things, then they add the logs. And it doesn't matter how many things you multiply, you can go ln of a, b, c, d, and you would get ln a, ln b plus ln c plus ln d. And you give me numbers for a, b, c, and d, we can punch in on both sides. I did that, I think, on Monday's video. And then you can say law 1, and then law 2, if there's a fraction and you have a over b, then you have log of what's on top minus log of what's on bottom. And the point of these 2 laws is if something's on top, it has a positive log. If it's on bottom, a negative log. Do you want to see what they're going to have you do? The very first section, they give you numbers. And 23 to 47, they have you expand stuff out with these 3 logs. I didn't mention the third law, I guess. The third one is powers. Take something to a power, And you can put the power in front as a coefficient. You can also put this back up as a power, whatever you need to do. Is there anything in particular you might be having trouble with, you want to see?
Honestly, I did this topic really well.
Okay. Very good. It's probably a repeat. If you took a good Algebra 2 course in high school, it's probably just a repeat. Math doesn't change. It has rules.
We went over a lot of this last year in pre-cal, I think.
Yeah, good. So yeah, this course is a lot of repeat of that. So yeah, in the third section, they start on this and then make you put it back together. Do you want an example of any of those?
I think I'm good.
Okay. I don't know, do we still have Mr. Clark? Yes, I think we do. Mr. Clark, you want to see an example of any of these?
I think I'm okay.
Same here.
Okay. Well, the very last topic was the very last section. How do you punch a base that's not LOG or LN? And would y'all know how to punch these things? Pretty simple if you know what to punch.
Yeah, there's like a little math area on my calculator, and I just go into math and hit log base, and then I can change the base and
Oh, yeah.
stuff.
Yeah, I forgot about that. They have that on the 84. I always forget about that. So I tell people to use ln of the 125 over ln of the 4, say. But yeah, you're right. These calculators do have a key that allow you to enter the base. Well, let me just pick one more, and then if y'all don't have anything else, I guess we can end the meeting. How about 55?
Sure.
Above page 395. They want you to combine this. ln of a plus b plus an ln of a minus b, and subtract twice ln of c. All right, so you don't want to combine until your ln's are by themselves. So any coefficient, there's only one you want to put up. Plus b, a minus b, minus ln of c squared. And then I call it the poof method. You want one ln, and because you have some positive, something's negative, you're going to have a fraction. Any factor that's positive is going to appear on top. The negative factor is going to be on bottom. And that's all there is to it. And you've probably seen that before. And then in the previous section, they had you take this and bust it apart. Any questions about that?
Nope.
I think I'm good.
Well, all right. That's pretty much examples of about everything. So unless y'all want to see anything else, are we ready to end the meeting?
Sure.
I got none.
Well, all right. Well, I appreciate you coming out late on a Thursday night. You'll have quiz 10 tomorrow.
Awesome.
Due Sunday. That'll be the last quiz of the semester.
Yeah, I got you.
Yeah.
All right.
Yeah, because next week we'll do 4.5, 4.6. That'll finish the class, and we'll just have a test over chapter 4. We won't have a separate quiz. And after that's the final, we can put this semester in the history books.
Awesome.
All right, then. I appreciate y'all coming out. And,
Yeah, of course. Have a great night.
Yep.
See you later.
Okay. Y'all have a good rest of the evening. Thank
You
you.
too.
Mhm.